We're going to talk next about trapezoids, and thankfully I have my wonderful little stencils here, and I have a trapezoid here. So I am going to draw a trapezoid. And so this is a trapezoid. Now, there are two types of trapezoids. There's a trapezoid, and then kind of in the trapezoid family, there's an isosceles trapezoid. And if you remember what isosceles means from triangle, from the triangle unit, it means exactly the same thing. Now, this is just a regular, not a regular trapezoid, it's just a normal trapezoid. And what I'm going to do is I'm going to label the points, and I'm going to give you the characteristics. I'm going to give you an area formula too. A trapezoid has one pair of parallel sides. Now, normally, when we're dealing with the parallelogram family, you have two pairs. You have your opposite sides that are parallel. In the parallelogram, opposite sides are parallel. Squares, opposite sides are parallel. Rectangles and rhombi, opposite sides are parallel. But the trapezoid is, like I said, it's another cousin of the parallelograms. It's just that whatever happened, something got screwed up, and those sides, is AD ever going to be parallel to BC, or are they going to hit somewhere? I can even put my fingers on them, and they hit way up here, right? So are they parallel? No. What are the two sides that are parallel here? AB, whoops, not congruent, parallel to DC. And a lot of times when you draw the parallelogram, what would be the slopes here? 10, 1, 0, undefined. They're both 0 because they're horizontal. Because horizontal segments have 0 slopes. Do they have to be 0? No, we could have drawn the parallelogram that looked like that. Because we don't have tape on our paper that only allows us to draw in certain ways. You could have drawn it like this, and we're getting different slopes. You can always move around the paper, and you can always get those different shapes there. Now, a couple things for just the normal trapezoid. And this is the key. AB is not equal to or not congruent to DC. Because if it was, then all of a sudden you would be in the parallelogram family. And that's the main difference between the parallelogram family and the trapezoid family, is the parallel lines are not the same distance. Or they're not the same length. And that leads us to these opposite sides, AD and BC. For a normal trapezoid, AD is not congruent to BC. For a normal trapezoid. So the really only thing that you can really say is that these two sides are parallel to each other. If you're dealing with a normal trapezoid. Now, I'm going to go ahead and go for the isosceles trapezoid. What do you think, just from the name, what do you think is going to happen when we deal with an isosceles trapezoid? Isosceles triangles have what? Two equal sides. So an isosceles trapezoid is going to have two equal sides. And that's going to make it a special version of the trapezoid. Because basically what you can do is you can take AB and move it around a little bit. You can move it to the left, you can move it to the right. And if you move it into a special situation where the middle of AB is right above the middle of DC, and you connect the endpoints, you're actually going to be able to create an isosceles trapezoid where the segments that connect A to D and B to C are going to be congruent to each other. And thankfully I have a stencil so I don't have to draw this stuff by hand because it's absolutely horrific to draw. But if you draw this, I'm going to do that right there. I'm going to scoot in a little bit too so you can get a little bit better vision of what's going on here. These are the midpoints. And you can kind of tell from right here that they're right on top of each other. I will call this E, F, G, H. So, since it's a parallel, or not a parallelogram, since it's a trapezoid, two sides are parallel. So we have to be able to find the parallel sides. Just looking at it, which two sides are parallel? EF is parallel to HG. Two sides are congruent. Which two sides are congruent? EH is congruent to GH. Awesome. Just kind of in the back corner would be perfect. Or right here would be perfect. Thank you so much. Bill is the greatest person on the planet. Bill Shreve, over at the print shop.
Oh, Bill, yes.
He's spectacular people. Yeah. But he is good people. Alright, so this is going to be a great video. EF is parallel to EG. These two sides are congruent to each other. That's basically it. Now, the cool thing is area. We haven't talked about area, but we will in a second here. This section right here is called the base. This section right here is called the base. Now the area is equal to 1/2 base 1 plus base 2 times the height. Now, how do you think I'm going to calculate height? There's your height. Now, here's the cool thing. If you rewrite this and you say it's base 1 plus base 2 over 2, what is that? Mathematically speaking, operation is that? When you add two things and divide by 2, what are you doing? You're finding the average. So basically what you do is you find the average of the bases of the two parallel lines, the bases of the parallel lines. And then we're going to multiply it by the height. And I'm going to kind of wrap it up as far as that goes there. This formula applies for this as well. The area of the bases, base 1 plus base 2 divided by 2, and you get your height, and you're good to go. Now, my highlighter fell, but I have another one. Like I said, these videos aren't going to be spectacular, but they're going to give you good information. Base 1, base 2. This is a formula for area that we are going to use for triangles. This is a formula that we're going to use for squares. This is a formula that we're going to use for rectangles, for parallelograms. It is all a variation. Believe it or not, when you find out the area of a triangle, it's 1/2 the base times the height, correct? You've already dealt with this. I know you have, because I know your curriculum. Yeah. Mr. Steve's class on February 14th has B-Lunch. Now it's immortalized in video. We are always going to use a variation of this formula. The average of the bases times the height. And when we come back from the break and we spend time on areas, you're going to find out that every formula, if you remember one formula as opposed to remembering 17 different formulas for area, if you remember average of the bases times the height, it's going to work for every single one. For a triangle, how many bases are there? Just really quickly. Here's a triangle. If that's my base, is there another base? So it's really base 1 over 2. So we're averaging one base times the height, as opposed to averaging two bases times the height. So it's the same equation every single time. And I always say, if you're stuck remembering equations, remember one. And then apply it to everything else. One last thing. Parallelogram. Let's go rectangle. That's base 1. That's base 2. That's the height. Now we know length times width, right? Area is length times width. But if we go area is equal to base 1 plus base 2 over 2, which is the times the height, isn't base 1 equal to base 2? If you're bowling and you score 100 and then you score another 100, what's your average? 100. So this actually ends up just being one of the bases times the height. So your area equation ends up being length times width or base times height. 100% of the time. Josh, you got a question? Because you always take the average of the bases. It actually does have a second base. The second base is a point. So that's base 2, which is actually equal to 0. Because the base has no length. So technically it does have a second base. So my job, part of my job is to make sure that you guys don't do more than what you need to do. And do you want to remember an area for a square or a triangle and a trapezoid and all that kind of stuff? Or would you rather learn one equation that works for every single shape? One equation that works for every single shape. So there it is. This works for every single quadrilateral that we're going to be finding areas for. All right, I've bored you with a 14-minute video for so long. 14. It's 14:43, and I will end it at 14:50. Remember, Mr. Steve, be lunch. Have a great day.